Okay, thanks everyone. So hello, I'm Kinuko from Google. I'm working on Chrome browser. I've been in browser and the web industry, but being able to talk about something in an event like this, it's something I'm not used to. So I feel very privileged and honorable. Thanks for having me here. So the main topic of my talk is about web packaging, but I also thought that it might be good to talk a little bit about Chrome browser itself and that the problem we are trying to solve, that's loading. So let me start with it. But before doing that, let me also still self-introduce myself. So again, hi, I'm Kinuko. And I'm a software engineer and manager at Google. I'm working on Chrome mainly for web platform. I counted how many major APIs I shipped. I think at least 6. But I also found that 3 have been already deprecated stuff. But it happens. But one got hugely successful, which is called the API service workers. You might have heard of it. I was a tier of Chrome implementation of service workers. I was kind of lucky to be able to be involved in because it's gotten huge successful, and that's used in many sites now. I'm also working on various projects, but currently mainly focusing on the problem that's called loading or page loading. I'm based in Tokyo, so if you are around, feel free to say hi, maybe on Twitter. I'm @Kin on Twitter. Oops. Sorry, something broke. OK, so let me talk a little bit about Chrome browser, because I often get some questions. I can't answer to everything, but I can try my best. So first question. So Chrome browser, it's supposed to be open source. But people often ask if it's real open source or not. I'd say yes. At least for every code I write in the review, it's public. Every code is public. And when I submit something, it's immediately visible on public repository. And the majority of contributors are actually from Google, but we are also having lots of contributors outside Google, many individual contributors, and also many commits from other companies, like Microsoft, of course, or Intel, Igalia, Samsung, LG, Facebook, and many. We are happy to welcome many commits from many communities. So another question I often get is that how big is it? I actually don't know, but here are some numbers. I did some a WC, and it told me that it's roughly 23 million lines. And I also did the Git log. It told me that in the last 1 year, we had at least 2,000 committers committed 83,000 commits. It's a lot, but if it sounds somewhat overwhelming, it's not my intention at all. It's huge code base, but we're trying really hard to keep it simple and silly, and we're trying hard to make it inclusive. It's somewhat modernized and it's modularized, so any contributions actually welcome. So how frequently it's released? So there are 2 types of channels. So stable Chrome, you might already know this, but it's basically branched every 6 weeks. There's another channel, it's called Chrome Canary. This one's a bit special, and it's actually released almost every day. So if I break something today, and you are using Chrome Canary, then you will see the breakage in a few days. So what language, programming language, it is used most? C++. I hope people are not running away. OK, so now I've covered some of the Chrome browser basics. Let me get back to the problem I want to talk about. So loading, it's basically about the process that gets something from the network and show something on the page. Think about it more. It's basically about how web is designed, how it feels today. For example, this is an ideal user experience I would want to have. If user types something, the information should just like immediately show up, and there should be no friction. But this would be the typical user experience on mobile web today. So user types something, browser does something, then content will eventually show up if you're lucky. It might be probably just OK, but what was the blank page you needed to stare at? So actually, our data shows that like more than 10% of page loads takes more than 3 seconds before it shows the first sign of content. And our data also shows that like 60% of loading time spent just waiting for the first sign of content. It means that your sites make users stare at blank page. This is not ideal, and this is a loading problem we want to fix. Let me talk a little bit about like when we have some problem on web platform like this, how we could approach the problem. There could be many ways, but from the browser people, I see that there could be at least 3 ways. The first one is improving browser engine. Second one could be empowering developers. And the third one is propose and ship new APIs. Let me quickly go through these. So improving browser engine. Yes, we build a browser engine that's called Chrome. So why not optimize that? So we do that heavily. So for example, like some of the talks yesterday covered that like moving things off the main thread makes it faster. And we actually do the same thing in browser engine. We also try to optimize IPC and how we allocate processes, because today browsers are multi-process thing. We also try to optimize memory allocation, and we try to predict what the next user action will be, and speculatively start something, or speculatively, for example, like fetch something beforehand. It makes things faster, but it's often not enough to drastically change something. So we need help or like a collaboration from developers. So we are also spending a lot to empower and help developers to give the appropriate or like helpful information and incentive to developers. For example, like we try to put millions of efforts improving dev tools or like Lighthouse. Or we also define metrics like fast content for paint and make them available everywhere, like in dev tools or like in every type of console, or also in APIs, like performance API. Today, framework also dominates how web works, so that we try to work closely with many frameworks so that we can collaborate more. The last thing we can do is like we try to change how web works today and propose and ship new APIs. Examples could be, for example, like a prefetch. In this way, sites can actually give much more accurate hints to browsers what page user would visit next. And the browser can actually start fetching things beforehand. Wasabi Circles could be a good example too. It actually drastically changed how page is loaded by inserting an arbitrary JavaScript execution layer in the middle of loading stack. So this could be very powerful, but could be very difficult, because if we just build something and that tells it like, hey, I think it's great, so you should use it. But it probably doesn't make every developer think that they should use it. So we need to be very careful having right iterations, work with developers to see that the things we're proposing actually address the problems that are being developers are having. So basically, I lead efforts in these 2 areas, improving browser engine and also proposing and shipping new platform APIs. In today's talk, it's basically about this one. Proposing, it's not shipped it, so new platform APIs. So let's step back and talk about what's the loading problem? Why does loading stand out that much? So I know there are so many techniques that try to hide the loading overhead. But for now, let me focus on the very basic fundamental things, how web works. So as you know, every resource on the web is basically represented as an address or URL. It's very beautiful architecture, but it's tough, When browser needs to load a page, it needs to go to the address, get things, and find out more addresses. So that it needs to go to the other addresses and get more things, and then find out more addresses. So it needs to repeatedly do this to load a page. It's creating the strengths of the web, but also making loading tough, sharing something tough, and exploration tough. So as I said, loading is basically annoying, and even worse, users don't know if it's succeeding or not while waiting. So it might be often the case that the user waits for a few seconds or even hundreds of seconds just to see the offline dino. It's not good. I don't think people in this event don't think that offline is the problem today. But it's often the case many developers think that offline is the problem today. But you might have experienced like this. In case you haven't seen this picture, this is a figure except from the legendary talk my colleague had about service worker and the instant loading. But anyway, so this image basically about toilet. So there are 5 cubicles, 4 are occupied, and somehow the building Wi-Fi coverage also works for the same 4 cubicles. What would you do? You probably need to ask your inner body and also your internal desire. There's a clear trade-off, and you need to deal with it. Or maybe something like this. I flew from Tokyo to Kyoto. It took about 9 hours. Yes, we have tons of in-flight entertainment system, but I often usually get bored very quickly and tend to just open Chrome, tap something, and realize that, oh, I'm offline. I'm so used to tap something on web, and still, when you are on the airplane, your connectivity is not there. You can pay to get connectivity, but it's not very cheap. And when talking about the cost to connect, there's more data. I think some of the talks today also covered the same topic, but let me talk about this. So this mapped from Alliance for Affordable Internet. So according to them, the cost to get 1 gigabyte of data needs to be less than 2% of average monthly income to the country to be affordable to everyone in the country. But this map is showing that we are not really yet there. And the same affordability report, it's just published last month, so it's happening today. It says that the billions of people around the world today are kept offline because of the cost to connect. So there are billions of people who want to access your content, but who might not be able to get daily connectivity to access to your content. And in these countries, public Wi-Fi is very popular, and also person-to-person app and content sharing is a thing. For example, for Android apps, Google Play now officially supports offline peer-to-peer app sharing with the mechanism that's called security metadata. But it is not possible on the web today. And when think about connectivity, as I mentioned earlier, so everything on the web is basically represented as a set of addresses. But what if your location makes it difficult to reach to the destination address? The traffic situation might not be really good, and you might need to get multiple transportation to there. And if your transportation is not available, your content is not there. You cannot just explore the content. And even if you are completely online, the destination address may be very far, or its shopkeeper of the destination address might be just temporarily out. And if so, you are out of luck. You knock the door, but get no response. And if that was for the critical content of your page, then you get just blank page for that load. So here's a simple question. Why don't we have a self-contained format like books on the web today? Then the content can be just like a pre-discovered, pre-fetched, and distributed, like bookstores. So here's why we have a proposal. So we have a proposal that's called web packaging, naturally, because that's the title of this talk. And it's a technology that allows a single or multiple HTTP resources to be packaged up so that it can be easily shared, delivered, and transferred from anywhere. They propose as IETF and the W3C specifications. We're not talking about specific product like Chrome browser or specific services. Web packaging consists of multiple spec proposals, but there are two important concepts. The first one is web bundles, and another one is signature. Web bundles, it's basically a format that can represent multiple HTTP resources. Today, a typical web page consists of multiple resources, as you know, like HTML, images, CSS, and JavaScript, fonts. And the web bundles can represent everything in a single resource. But when a user gets a package like web bundles, it's like important that the user can verify where it's coming from. Otherwise, it's just a bunch of resources, and user cannot feel safe to browse that. So web packaging also offers a mechanism that's called a signature, so that the browsers and the users can actually verify where it's coming from. Let's take a closer look at the first concept, that's web bundles. So it's, again, a basically format built into browsers, specifically designed for bundling HTTP resources. Because it's built into browsers, it doesn't require JavaScript to pass resources. So it's similar to JavaScript-based bundlers, but it's kind of like a browser can natively understand the content. And unlike legacy HTML archiving format like MHTML, it itself can also execute JavaScript. So your live page can be just packaged. Your web apps can be packaged, and they can be distributed. And there are several other unique characteristics. But the important point is that once bundle is locally available, loading it's very fast. It's nearly instant. So let's see if it's really instant. So this shows the comparison between the web and the web bundle. Web bundle one, it's already locally cached, so it might not be really fair, but let me show you how it performs. So like this. So web text sometimes still loads the page, but if web bundles are already pre-retrieved on your device, it's really instant. And I want to make this experience available to every page. So there could be several interesting use cases, but the first and simple basic use case could be casual save and sharing. So imagine that the browser provides a feature like let you save a page that currently you're browsing as a bundle. Then users can freely just like save a page as bundle and browse it later without worrying about connectivity, or just can share that with others. And we're planning to make it happen in Chrome. But browsers cannot know everything about every site, so sites can also craft their own packages or own bundles to provide much better UX, maybe as a bite-sized consumable content. Then browser can also discover that, and they can save that instead. Then your site can provide really good self-contained user experience with the bundle. So let's think about this scenario once again. In flight, your friends uploaded a nice web game as web bundle and started playing. You feel jealous. Oh, I want to play that too. How would you do that? But if you have web bundles, it's easy. You can just get that via P2P file transfer app and then can play that. You don't need to take a time using the same device. You and your friend can just compete. It's fun. OK, so let's now take a closer look at another important concept, which is signature. So packaging offers a way to digitally sign an HTTP resource so that the browsers or users can verify who published the content. And the content is really the original one. And also how, like when it expires, or like if it's still valid or not. If you've heard of web packaging before, you might have also heard of the feature that's called Signed HTTP Exchange, or SXG. It's also a part of web packaging. And Chrome actually already ships this one. But it's basically about a single HTTP resource signed by an origin. This means that now HTTP resource can be retrieved from anywhere, for example, from a fast cache, from IPFS, or from anywhere. And the browser can still treat it as if it's coming from the original origin. It's very powerful. And today, Google Search adopts this to make the search results load faster using its own cache. It's called AMP cache. So now that we have web bundles and the signature, it makes it possible that your web content can act like real books. You can publish signed content and can share between people, or can pre-distribute them to devices. Let me introduce one more use case. So you probably heard of PWA, or progressive web apps. It's supposed to work offline. And today, now it's also possible to install it from Play Store. However, Service Worker doesn't solve every situation. For example, if user install your PWA, or it's called a TWA on Play Store, and then what if user taps it first time, and while user's offline? It just results in offline error. It's not ideal. And the very first initial user experience would be really critical for your app. And the web bundle can fix that. So I've talked a lot about the use case, but let me also talk about how you can try creating your own bundles. So there could be several ways, but if you are a site developer, or you have the access to the site's source code, it can be very simple. You can build a site and run the bundling tool to get the bundle for that site. It would be simplest and easiest. But if you don't have access to the site, you can also still create a bundle from a list of URLs or from some archive format of HTTP. But this could be tricky, and I wouldn't recommend that. But anyway, so there's a command line tool available on web packaging spec repository that's somehow written in Golang. But as far as you have a Golang environment, it's very easy. You can install that by running goget. And there's a command called gem bundle, so that you can create bundles from a list of URLs, or from a local directory that contains all resources, or an HTTP archive file. But we figured that it's not the case that every developer has a Golang environment. So we are also trying to develop experimental node.js module, which is also called WBN. It's still very experimental, but you can try it by typing npm install WBN. It provides very simple API. It's very easy to use. You can create your bundle from using node.js. So let me show you how it could work with a real site. So for this example, we chose 2 MVC done in Preact. So all you need to do is basically just clone the repository, so get the repository and build the site to make resources available to be bundled. And then you can just run the bundling tool. So this one you just go to, but anyway, so Node.js programs should work too. But anyway, you can bundle everything. Then if you have Chrome Canary and you enable the particular flag, just drag and drop the file into the browser. Should make it work. It's simple and fast. It works offline too, of course. And in Chrome, we're trying to make more pages like this, discoverable, so that when users offline, users can still explore various set of contents that are available and they can load instantly. We think that creating bundles, your bundles could become a packaged gift for the billions of people who want to access to your content, but in a limited connectivity. So if you are a site developer and you are the type of person who likes to try out bleeding edge technology, we really appreciate that you try this and give us feedback. We know that it's very important to get feedback from developers so that we really, really appreciate that. We also appreciate your contribution. So that's a wrap. Thanks a lot. If you have feedback, you can reach to any of these addresses. Or if you are interested in contributing to Chromium, it's also very welcome. You can visit this site. And if you are interested in playing the web game mentioned in the talk, you can try this address. The latter one, bundled one, requires it will let you download if you're not using Chrome Canary and you haven't enabled the flag, so be careful. But if you do that, this should just work. So thanks a lot. That's all. Hope you enjoyed this talk.